Welcome to this amazing physics course, and we'll be introducing physics right to you guys, and we'll get to talk about a lot in this course. Physics is an amazing course, and um, it's one of the important courses to take if you would be doing sciences, and um, physics is one of um, a course you have to do as a science student. You must do physics in your university or in your secondary school. So it's going to be an amazing journey for you to join me in this physics journey. It's going to be easy. I've broken it down into understandable pieces for you to pick up. So do not fear anything and just dive in right with me on like you see on the board. We'll be introducing physics and physical quantities. Without wasting any of our time, we can just go right straight into it. Now, we all know that physics is a branch of science because it is a study of science, a branch of science that deals with the relationship between matter and energy, mostly the behavior of matter. I would say that physics is a physical science that deals with the study of the behavior of matter in relation to energy. And because in sciences, studying involves lots of experiment, and in physics, experiment deals with a lot of measurement of physical quantities. That leads us to what we call physical quantities. I would say that physical quantities are those measurable properties of a body or phenomenon. For example, you want to measure how hot or cold a body is, or how hot or cold water is. You want to check the temperature. You get to measure the temperature of the water to see if it's hot or cold. Now, those measurable quantities, those measurable properties of a body is what we call physical quantities, like you can see here. You want to know how long it took an object to fall down. You want to know how long it took you to get to school. You'll be like, how much time do you spend on the road coming to school? That is because the event that occurred or you trying to come to school, it's a measurable property or phenomenon where you can measure it in terms of time. You can say it took me 1 hour, it took me 50 seconds, it took me 30 minutes. Those measurable properties is what we call physical quantities. And we can further divide physical quantities into two. The first is the fundamental quantity. And we say that the fundamental quantity are those basic quantities that are independent of any other quantity, and other quantities get their definition from them. We say that fundamental quantity are those basic quantities that are independent of any other quantity, and every other quantity depend on them for their definition. Example of the fundamental quantities: the fundamental quantities. Remember, physical quantities, sorry, physical quantities is divided into fundamental quantity and derived quantity. Derived quantities. I would say that fundamental quantities are those quantities, they are the basic quantities that are independent of every other quantities, and other quantities depend on them for their definition. And we also say that fundamental quantities have fundamental units. The units associated with fundamental quantities are called fundamental units. Examples of fundamental quantities are: we have the mass measured in kilogram, denoted as normally we can say m for mass, denoted as m at some point. We have The second one, we have length, measured in meters, denoted as m. Yeah, sometimes we can denote it as m. We can denote it as m. Capital. Okay, let's call mass capital M because we denote mass as capital M. Then we have the time measured in seconds, denoted as S. Seconds, denoted as S. We have the temperature measured in degrees Celsius or Kelvin, Celsius or Kelvin. We have electric current measured in ampere, denoted as I. We have the amount of substance measured in mole, denoted as mole, etc. We have a lot of them. So let's go to the derived quantities. I would say that derived quantities are those quantities gotten from the combination of two or more fundamental quantities. So for us to be able to get a derived quantity, we have to combine two fundamental quantities to be able to get it. Hence the word derived, gotten from something. So examples of derived quantities are we have the area, which is length times breadth. Length times breadth. Length is measured in meter, like we know from here. Length is measured in meter. Breadth is also measured in meter. Breadth, height, width, length, all of them are measured in meter. So when we multiply meter times meter, we get meter squared. So the unit of area is meter squared. Then we have volume. Now length is a fundamental quantity. Breadth is a fundamental quantity because meter is a fundamental unit and meter is a fundamental unit. Hence, we get a derived unit which is meter squared for area, proving what we said that derived quantities are quantities gotten by combining two fundamental quantities. Length is a fundamental quantity and breadth is a fundamental quantity as well. So let's do for volume. Volume is area multiplied by height. Height is also a fundamental quantity because it's measured in meter. Area is a derived unit as well. So area is meter squared. When we multiply them, we get meter cube. So the unit of volume is meter cube. Then we have speed. Speed is distance divided by time. Distance is also measured in meter. Meter is a fundamental unit. Time is also measured in second. Second is a fundamental unit. So speed is the unit of speed is meter per second, or you can write it this way, meter per second. Then we have velocity. Velocity, also the same thing, but this time around is displacement. Displacement over time. Displacement is also measured in meter, and time is measured in seconds. So both of them are still the same thing, meter per second. Then we have acceleration. velocity over time. We know that velocity is equals to meter per second and time is measured in second again. So when this one, from your indices, when this one goes up, it becomes meter per second square or meter per second square. So this is the unit for acceleration. Then we also have force. Force is mass times acceleration. Mass times acceleration. Force is mass acceleration. So we say mass is in kilogram. Remember, the unit of mass is kilogram. Kilogram times the unit of acceleration is meter per second. Meter per second. So the unit of force is kilogram meter per second square or newton. You can say newton. We'll get to this, and we have a lot of them. We have so many derived units and so many derived quantities. A lot of, and we say that the unit of derived quantities are called is called derived unit. And okay, let's take another one. We have pressure. Pressure is force over area, and we know that force is kilogram meter per second square or newton. Let's use newton here over area is meter squared. Area is meter squared. So we say that force is newton per meter squared or newton per meter squared. You can write it this way. You can write it this way, or you can write it this way. They are all the same thing. So that's for derived units. That's for physical quantities. Next, we are going to talk about